Happy to have Tom Coffeen from Limelight here.
Tom Coffeen from Limelight. Was it just me, or did Vince Cerf bear a disturbing resemblance to Dr. Breen from Half-Life 2? Anybody else notice that? Okay, I'll go over briefly what Limelight has done with v6 to this point. I was here last year, and we had just turned up v6 in the core, and that was prior to us engaging in a proof of concept a demonstration of v6 content with Netflix. Since then, I had hoped to have a lot more progress to report, but Limelight is in a relatively awkward position of basically having to wait on the content developers and the content providers to generate demand that compels us to then support v6. I've done as much as I've been able to do as sort of our official evangelist within the organization to get people excited about v6 in the organization and recognize that the technical challenges that we're going to face in adopting it are better approached earlier than later, as we learned with the deploying in the core and getting the v6 Netflix demo up. And I think it's a common story for folks who've done it to this point. I mean, Facebook, great example. I detected the note of a bit of shock that it was, as easy as it turned out to be. We had the same type of experience with much of what we did initially, things that just worked right out of the box, things that required very minimal amount of configuration change, and so basically all the low-hanging fruit has been grabbed at this point. But going forward, we're really at a point where until we actually get some of the business demand driving v6 adoption within the organization, there's not a whole lot of resources that I can sort of get pushed in the direction of getting additional v6 services up and running. What we have to this point, though, just to go over this slide quickly, IPv6 in the core, we've had that for a little over a year. We'd like to think that we have minimal time to provisioning v6 at the CDN edge, that it's something that we'll be able to offer any customers that come along and say, we definitely need this today. Again, it hasn't, the demand hasn't necessarily been there, so it's tough to see where this will fall over, if anywhere, when tested. We have v6 transit to, actually, this slide needs to be updated. We have v6 transit to 4 providers, peering with critical networks. Obviously, as a content delivery network with its own backbone, peering is pretty critical to us to get traffic offloaded as quickly as possible. We've had quite a bit of luck with providers who've been willing to peer v6 with us. And I don't anticipate that's really going to be a problem going forward. The issues aren't necessarily in the core as far as getting folks aware of the need to get v6 up and running. We're currently using a parallel DNS architecture that allows us to serve Netflix over v6. We did that as a requirement to keep our v4 production network stable, to make sure that we didn't have any issues with our DNS architecture that provides the secret sauce for our content customers. And that's something that ultimately we need to synthesize into one DNS architecture for reasons of performance. And it's something that again, until we actually have more demand for v6 services from customers, it's unlikely to happen. We're delivering v6 traffic to eyeballs today and providing v6 transit today to several customers, and obviously being here represents close engagement with other industry IPv6 early adopters. And something I certainly hope to take away from this is some ideas of where to go next in the absence of actually having true demand from our customers. So some things that remain to be done for us, and again, until we have that pressure from the business side, it's a real it's sort of a really open question as to how quickly these will be addressed and in what order. IPv6 functionality for all standard CDN products. The CDN product offering for Limelight is pretty vast. There's a lot of services that that are sort of either represent corner cases for customers where we've built a custom service, or perhaps there's a portion of the service that, well, in any case, again, it remains to be seen how much additional work there will be to enable v6 for a lot of the product offerings that we have. For each silo within our organization, we've got a sort of mixed bag in terms of buy-off on v6 adoption, and in terms of status, if they've bought off, like actually where they are in terms of adopting and deploying. Most critical to this is probably on the finance and billing end of things, where a lot of our back office systems, some of which are sort of homegrown and hacked together, and others are more turnkey and appliance and software package type things. It's really a big question as to how much additional effort is going to have to go into those systems to allow us to fully bill and support v6 for the customers when they show up. So that's something that we're still struggling with a little bit. And then something that I'm trying to get a handle on is exactly what is driving v6 adoption where customers are asking about it, and if they're not asking about it, why they aren't asking about it. In other words, we're trying to get our sales force engaged to the point where they know how to articulately ask, what's driving customer either interest in adoption or lack of interest in adoption. And I think those data points will be helpful for us to try to push things from the other direction in terms of encouraging customers to think about what v6 adoption is going to entail for their own organizations. So it's kind of backwards in the process, but I hope that that there's an opportunity there to to really sort of drive things from a different end and get more customers interested in tackling the v6 problem up front, which will in turn really put pressure on our own adoption efforts to see where the weak spots are, where things that we haven't actually taken care of and gotten working yet, et cetera. And ultimately, okay, so yeah, things like that we've been talking about, such as NAT in the core, been talking about over the last year for much longer than that. NAT in the core, broken geolocation, broken DNS resolution, things that will negatively affect existing services. I'm hoping that some of that will be sussed out by, an effort to find out why customers are interested in adoption when and if they are. And then ultimately the goal is v6 functionality for any Limelight network product or equivalent v4 workaround. So, obviously we just want things to work, and v6 is one solution to certain challenges that we're going to face collectively. As I evangelize within the organization, I try to make that point as frequently as possible that, v6 is what we have to do to make v6 work is one possible solution. If we can, if there are things that we can do to make v4, get the job done, and perhaps Facebook's success with Lisp is an example of that, in terms of a very small v6 footprint. Current projects, v6 limelightnetworks.com, that's up and running. We're trying to get v6 SSL working for Netflix in particular. We've got issues with the load balancer that we're currently using, and that's something that we're in the process of trying to tackle with the vendor. Synthesizing the v4, v6 DNS architecture, as I mentioned, doing things like getting v6 enabled on the corporate LAN segments, and then looking forward to, at some point, actually whitelisting all of our space for access to v6 services over Google. And geolocation for IPv6. We're testing the Quova database currently and have had some luck with that. It remains to be seen how quickly we can get existing products that are relying on Quova, our Quova database implementation, to actually use the v6 geolocation piece that they're offering. And then finally, maybe of some interest to folks here would be the amount of traffic that we're actually seeing over v6, being that we're delivering it to clients. And this is a quote that caught my eye from Martin a little while back, and I thought what was rather amusing about the quote was the 30 times ratio that he mentions, without necessarily providing a base number to apply that ratio to. So in the spirit of that particular quote, here's some graphs. Probably without the actual y-axis being provided there, what's of most interest is the fact that the traffic is still very bursty. We don't really have sustained v6 traffic levels. Those are all single sessions of people accessing Netflix over v6.
It is bits per second.
Yeah, it is. That's right. Yeah. So you can interpolate from that. And I mean, that's basically it. If anybody has any questions, we'd be happy to attempt to answer them at this point.
Thank you. We have 5 minutes for questions or so. I have a question. Oh, go ahead.
No, please.
No, I was just going to say I don't really understand the interface between a CDN and its customers. So who has to deal with like logs analysis for v6 addresses? Like if you just started serving, I mean, like. Do they have to audit their systems as well as you auditing your systems?
That's a service that we definitely provide, and that's, there's a big question mark as to what amount of effort will be required to support log collection. We know that we can do it today successfully, but the question, as with many of the v6 services that we've turned up, is to what degree will it scale? It's a question that's impossible to answer just based on the lack of actual v6 traffic and the lack of v6 customers. So again, once things start to ramp up, there are actual portions of our offering that seem to work very well today that we're not necessarily 100% confident will scale. So I hope that answers your question.
Yeah, that does make sense. Yeah. Thank you.
That's it.
All right.
Thank you.
Thank you, Tom. Well, for those that don't know, Lorenzo is the tech lead for IPv6 here.
Oh, is that working?
Yeah.
It's all right.
And we've been at it for the last 2.5, almost
right.
3 years, 2.5 years.
Only? Feels like longer than that. But,
yeah, September, August of 2007.
Oh yeah.
Yeah.
Okay, so I think a lot of you will have seen and heard me speak before. So I'll just touch on a few key points of what I think are the most important issues that we're facing. Number one, I still see in many other networks, especially content networks, because access networks seem to be now saying, "Oh dear, this is really, really bad. We need to fix it." And they're coming to content providers and saying, "When can you give us your stuff?" And we don't know. So again, why is this? We know all this. This is a nice way to present it, right? We had 50% of the space free 10 years ago, and now we have, well, it said 10%. Now, Takashi-san's counter says 6%. So the writing's on the wall, right? So I don't think anyone disputes this anymore. But what are the implications? So people are going to buy addresses, or they're going to do double NAT. Double NAT's expensive. It's hard to manage. It increases operational cost. But for a content provider, the major points are the ones that Jason already made, right? So what's the semantics of an IP address? Well, how do you geolocate it? How do you block abuse if somebody ends up on some blacklist? Does he take out all his neighbors? And if you don't want to take out all his neighbors, then how do you build your infrastructure to detect and intelligently moderate those spikes so that it doesn't sort of DOS your backend systems? Then, port exhaustion, one I think he didn't mention was port exhaustion, HTTP intercept. So when the user runs out of ports, I think the broadband forum recommendations for that are to intercept HTTP connections and put a helpful warning message with "You have run out of ports. Please contact your SP. You may have a virus." And while that's nice for the user, it's not nice for people that want to deliver content or advertising or you name it. So these are bad things. So there are strong reasons for a content provider, and these are the reasons that drove us essentially to implement IPv6. And also the lack of v4 space and the pressure on port exhaustion. If nobody does v6, the pressure on port space will go up higher and higher, right? Because assume that no one's moved to v6. The transition has somehow failed. This is a sort of extreme scenario, but what happens then? So the pressure on port space goes higher and higher. We crank up the use of one IP address more and more. More and more users are behind that IP address. What happens? Your timeouts, your NAT timeouts have to get shorter and shorter. What happens on the content side? Oh, my EdgeX application is not working. Let me crank up the keep alives. And so basically you end up in an arms race where the application sort of stops working at some point because the connectivity just isn't there anymore. So this is, this is 10 years, 20 years away or whatever it is. In internet time, it's probably more like 10 years. But if we don't move to v6, this will become a problem. So you can do NAT, but you can only do it so far, right? So ultimately, we have to move to something else. If you look at the population curve, I have a graph on my other computer, of course, but the dog ate it. But there's this nice little curve of world population, and there's this nice little flat line that's about just over halfway. That's the number of IP addresses on the whole v4 internet, right? And the number of addresses is lower than the number of people. So ultimately, that will be a problem. So, okay, technical constraints, v6 only deployments. Mr. Byrne there is eager to do v6 only. There are various things that can't be numbered out of v4 space anymore because there's just too many of them. The RIRs are being reasonably strict about handing out v4 blocks, so it's not very easy. And networks have been numbering their set-top boxes out of private space for a while now. So if you want to get your content onto those set-top boxes, then you need to be able to speak v6. New applications, yes. It's not clear to me how this will pan out. It would be nice to think that v6 will restore end-to-end. For that, we need either people not to firewall, or we need a solid protocol to open holes in firewalls. Now, to me, a protocol for opening holes in firewalls and no firewalls is effectively the same. I don't understand the difference, but maybe somebody does. No, there is no killer application for v6, or rather there is one. Yes, it's called the internet. If we want it to keep working, this is what we need to do. So we can't enable v6 for www.google.com. You know that. If you're at home, you do host ip6.google.com. You don't get an address. From here, you might. You do. That's right. You do. Here we do. So this is where I sort of say this is what pretty much how we think it should work. We're pretty close to it. So you have www.google.com. It's dual stack, and you can ping it, you can connect to it, you can run TCP dumps. And it's 3 milliseconds away because it's in the same place as before is, right? So, right? So this is what we want to reach, a situation where the content side is ready for v4, v6 in the same way, provides the same level of SLA. And of course, we're not there yet, especially, there's a lot of Wild West type situations in home networks where we just can't provide this level of service, but this is the goal. And this is what we need really for a successful transition. So I don't know if any of you have seen this before. You can do it on your own laptops, just connect to Google Guest v6 and get a glimpse of the future, if you will. Let's see if I can. I mean, the demo gods, I'm sure, will be against me. If I remember my password right. Yeah, that's not going to work. Come on. Okay. So, all right. Oh dear, there's a lot of traffic already. Let's see. That's my favorite expression. Anyway, so if you wait. Okay, so I mean, ideally, you should be able to, let's see, just do this and just see the packets flowing, right? And again, this is seamless to the user. It just works. So this is what we need, right? The packets just flow, the application keeps working, and it'll work, and 5 years from now, it'll work better on v6 than on v4. But that's only because we've done the back-end work, right, to make it happen. YouTube is the same. If we, I mean, if Eric had run the Vint video with a TCP dump behind it, he would have seen the packets flow over v6. So that's what we think is the way forward, and the only way forward, really, because there's just too much variety out there to have a single model. We have to provide both services for, you know, years and maybe decades. Anyway, to get back to my point, so we can enable it. There is no technical restriction on our side. Can you see this? Not really. There is no technical restriction on our side, or even at this point, scaling restriction to providing the service for everyone. What is holding us back is that we know that, you know, about, again, the numbers are 1 in 2,000. 1 in 2,000 users won't be able to get to us anymore if we do this for the whole internet, and that is a high price to pay, and it's unacceptable at this point, right? So that is why we started with whitelisting, and many of you know how it works. Basically, if your resolver is in our magic list, it will get v6 addresses for all our properties, just like you do here today. People like it, but the problem is that some people turn it on, and then their users say, "Oh, I can't get to Google anymore." And did you call your ISP? No, I didn't call my ISP because it's only Google that's broken. So it must be Google's problem. And so this is a problem for us. So and this is the reason why we have to be very, very careful in turning the service on, because we don't want to provide a lower SLA for our users, and because our users might not know anything at all about what went wrong. So this is really the big challenge that we have at the moment. And so, you know, everything else works. They won't call their ISP. They'll just, you know, go somewhere else, which is not what you want if you're a content provider. So we'll talk about that tomorrow. We'll talk about what our numbers are like, what the causes are, you know, what we know. We don't know that much yet, but we do have some pretty solid data at this point on sort of, you know, millions of data points a day. So we do have some knowledge. So we'll talk about that tomorrow. Something from the network, some lessons learned just from our experience. I mean, we've been at this for a while, and we have pretty solid infrastructure at this point. The implementations do mostly work, but they do have bugs because nobody's really kicked the tires, right? You run it, and there are some bugs on the next slide that you think, well, but how could I have found that? So yeah, don't expect something to work just because it's supported. That's something that you know as network engineers. One thing that's useful, that we found useful, is if you find a bug in the lab, you report it, and you keep going because you need to find the next 10 bugs. And what was useful for us is find the 10 bugs, report them all at the same time so they all get fixed in the next release. You don't have to wait 1 bug per release, and because then you'll never qualify. And some people have been saying, oh, I'm trying to qualify, I won't say the version number because it would give away the vendor, but I'm trying to qualify version X, and this is my 3rd try and it's not working, and every time I find a new bug. So don't do that. Try to find all the bugs at the same time and then get them fixed in the same release. And one thing that you might want to consider is if you can work around the bug in some way that will survive production use, trial it. Because I guarantee that once you trial it, you will find another bug. And this bug will be very strange. So here's some examples. So if a firewall filter has a 1-bit match in bits 32 to 64, and then just after that a 2-bit match in bits 64 to 96, then the second match will not work. How do you find this in the lab? You get very lucky. Or you put it into production and you see what happens. So in particular circumstances, the fib and the rib may get out of sync due to race conditions when pushing updates. Are you going to find that in the lab? There's a better chance of that, yes. But maybe still, because you need particular flapping scenarios. One of my favorites is if you loop a link for backbone testing. If your circuit vendor loops the links, you trigger DAD, duplicate address detection. Your interface goes down. ISIS points that way because the shortest path is that way, and your traffic gets black holed because it fails neighbor discovery. What happens? You can't shut down the interface because that doesn't fix the problem. You have to deconfigure the interface. Now, so what do? Well, luckily, in the release that we are running, you can disable duplicate address detection, so you can do that. But if you're running a release that doesn't allow you to do that, you're stuck. So, oh, and if Linux gets a packet too big message on a receive-only interface with no route pointing out of it, it ignores it. How are you going to find that? Well, again, you might find it in the lab if you're lucky. But the race condition of the fib updates, we found that after months in production on a reasonable number of data centers. So it's unlikely enough that you might not see it in the lab at all, and it is enough to break your v6 routing and to break your service. So test and trial if you can. So yeah, this is, I think, at this point, our strategy is well known. We started with a band of volunteers, a band of volunteers. We used our 20% time, and then somehow we managed to get something out there and to sort of get a snowball effect. And I think, at the last step, management got involved. This might not work for you. It did work for us because Google is a very engineering-driven company. But your mileage may vary. But ultimately, management involvement is necessary. So you do need buy-in. And I think the reasons that I was talking about earlier, those are the reasons why we really need v6 to keep stuff working. Right? It's a business continuity issue. Yes, don't go out and buy gear for v6. Just fold it into your normal upgrade cycles. We started in mid-2007. We had all our services running in late 2008, early 2009. We turned on the whitelisting program, and then we turned on maps. We turned on YouTube. Took a little longer to get those services done. YouTube in particular was a hardware issue. Particular vendor gear just didn't do v6 in hardware. It fell over at 100 megabits, and it's not acceptable. And there's a lot of work since then that has gone on behind the scenes to make the implementation more solid. But one of the luxuries we had as an early adopter is that you don't need to be as careful when you're not throwing 100% of your traffic at it. Just a few statistics. These are I haven't looked at these recently, but I think they're still pretty much accurate. v6 is growing. It's very small, 0.2%, 0.3%. It's all in France because the French thought of 6RD first, and they said, hey, let's deploy it. And they have a few 100,000 users opted in, and they all come in every day. They clock in over v6, and it's fine. I think Gunter will be talking about this tomorrow. Please don't use 64. Please don't use Torito. Please invent a time machine and sort of remove it from the RFC list or something. It is a real problem, especially 6-4, especially implementations that try 6-4 before v6, before v4. And this is our graph. As you can see, it's a little bit. This was the launch date. That is lunchtime, as you see. We turned it on, and when we thought, oh, okay, we'll go to lunch now because can't possibly break, can it? That's not true. But anyway, this is the graph. You can see that traffic when you turn on quad A's, since negative replies aren't cacheable, the traffic just goes up straight. Bam. Our graph is a little bit more smooth. So there, of course, we don't have axes either, but there's a smooth aggregated traffic here. You can see that from the graph. And that's it. As I said, we will be talking about whitelisting more tomorrow, and looking at the challenges we face and what our data looks like and what we think the problems are. And we don't have the answer at the moment, and we hope that discussion will stimulate answers for us as well. Thank you.
Got time for questions? Martin Lee, Hurricane Electric. In a purist world, we could all agree with your 6-4 statement, but in a real world, we can't. It exists, it's out there, and as you and I have discussed, we've spent a lot of time trying to at least correct what's out there. It can never be perfect. The sucks less comment is a more negative way of saying it, but at least it's getting better. How can you convince more and more service providers to at least do some form of 6-4 work earlier? We had this discussion with John from Comcast earlier. But how can you convince them to do more work in order to improve things and at least deal with their own users when in a way, you're trying to sort of say, let this problem go away by not discussing it.
So the problem is that 6 to 4 is so, and the question is why, for example, and one of the follow-up questions to that was why do you not run your own relays, right? And the problem is that with 6 to 4, it's the last mile, it's the last link that's the problem. You get these packets coming out of 6 to 4 and they just die.
So that's why I said it's an access providers issue. This is something that John understood at Comcast and other people have slowly started to understand. So at least dealing with this traffic has improved things, maybe in some cases dramatically. There's an awful lot of traffic being relayed. I know we are, and other people are doing it as well. But it's not a case as a content play. It's not your responsibility to run a 6 to 4 relay.
Oh,
but
it is. It would be. It would be.
Only to a very slight extent compared to access networks.
Oh, not a relay. Okay, but our own routers, yes.
So why not take a different approach and sort of, instead of trying to get it ignored, why not go out and use your, if I can use it, pulpit to convince more and more access providers to actually focus on this?
Say can convince the OS manufacturers to disable it by default.
That history, it doesn't work.
No, that's the only way. That's the only way we can get past this problem, because there are gateways out there in home networks that are announcing RAs and that black hole packets, and they've been sold and they're in the field, and nobody is going to upgrade them and nobody is going to replace them, and that's the 1 in 2,000 users, and that will not change. The only way to get around that is to you can't make it work. You have to replace the CPE. If somebody has a vendor X box in his home network that doesn't do V6, that says, oh, here, I'm a V6 router for you, and I'm going to black hole your packets real well, what do? You tell the user somehow, you find them, and you tell them, please upgrade your box. How are they going to do that? You tell them, the most you could say perhaps is, here's a new box. But that's not something we can fix, right? But the OS manufacturers could fix it. Right. So the question was, on any given day, how much brokenness on V4 do you have? The answer, the easy answer, and the sort of the easy answer is we don't know, but that's not actually true, because we do see flakiness, and our measurements are good enough at this point that we do see non-zero brokenness over V4. But I can tell you that there's a nice measurable difference there. And when you're trying to go to a service owner, right, and say, we can do this V6 thing, and it's about 5 times less reliable than V4, what's the service owner going to say? So and with that said, I agree that 6 to 4 exists, and we should run our own routers. Various things make it hard for us. I think we should do it, frankly, from the front ends instead of doing relay traffic. But that's just arranging the deck chairs, right?
Right.
Yeah, that's true.
So about the percentage of the IPv6 users, for me it's not surprising. It's still small because we are now trying to solve chicken and egg problems. But I'm curious about whether other Google people understand or have the longer term view for the need for the migration.
Do you mean, does our management understand that we have to do this?
Or other engineers not focusing on network related issues?
Awareness is spreading. That's certainly a challenge, because typically application developers may not have specific knowledge of networking, especially when you start to become a large company. They focus on their applications, and they have clear boundaries between their applications and the rest of the world, and the packet is coming in through Magic, and I send my packet here and it goes out through Magic, right? There's a lot that can be done, especially if you have a sort of common source space that everyone can access. There's a lot that can be done by providing shim layers inside your code, or by protecting pieces of code may not be v6 ready. Steiner's going to talk about all of that. And so you don't necessarily need awareness before you start providing services. You need awareness for the last, 10% or even 1%.
Oh, my question is about whether if they just don't need to care about that, that's fine. But if they even try to drop the idea of migration due to the smaller percentage of users, that's what I'm afraid about. So,
you make it clear that that's not acceptable, that this is not going to go away.
okay.
And I think that message has come around, at least at Google. It's clear to people, and that's why I say ultimately you need management buy-in from this, because ultimately, once management knows that this is not going to wait, it just becomes a matter of time, right? It will happen, and so that's one of the ways to attack the problem. And the other way, of course, is if you get a service serving v6 traffic, and you pass them live traffic, and they introduce a regression that breaks their service, they're going to find out real quick, and they're going to roll it back.
Yeah, of course.
So there's that aspect as well.
Okay. Thank you.
So on the issue about 6-4 and whether it's a good or a bad thing, I'd like to offer an alternative view that says that it's actually a very good thing because it's causing a lot of angst and a lot of urgency to get things fixed that might not otherwise have occurred, right? To Martin's point, service providers can fix this. Your issue really is that an unmanaged thing is getting in the way of your managed service and the managed services of the last mile delivery. Well, as long as people are doing managed services, the 6-4 never comes into play. It's the fact that you don't have the managed service that you want, and this automated thing is out there. It's creating a little bit of urgency that I think, so it's actually a good thing because it's causing people to wake up and pay attention in ways they might not otherwise have paid attention.
Well, it's not causing the users to wake up and pay attention, and then the users are the ones that own these boxes. But sure, I suppose every cloud is a silver lining.
Yeah, the point I was going to make, Tony, half of your point was my point, that the best way to fix the 6-4 problem is for the service provider to provide a v6 managed service, whether it's 6RD, dual stack, or what have you, because then the hosts won't try the 6-4 anymore.
Not really.
Come on.
Not really, because a senior network engineer at Google happened to buy one of these gateways and noticed, because he's a network engineer, that he wasn't using his Hurricane tunnel, and he didn't know why. And then he ran a sniffer, and he said, "Oh, but this box is sending me v6 root advertisements, and my machine is picking them because they're the most recent ones."
The most recent?
I don't know what, but he was using.
If I'm an OS and I get a 6-4 and a global, the source selection policies, I think, will always choose the global.
The router advertisement provides you with two pieces of information. One is the root IP address of the default gateway, which is link local, and another is a prefix. That information is not necessarily tied together. You know that, right? It's the RA gives you default lifetime, and this is my link local address, and then it says these are your prefixes. So the stack simply says, well, these two pieces of information are not necessarily correlated. I'll use the lowest router ID, which is what most implementations do, right? Or the most recent one. And of course, he went into the control panel, and somebody reported it on Nanog. Here's how you turn it off. You go to this hidden web page, and you go to, I forget what it was, system.extension, and you click here, and you unset Windows Vista Ultimate compatibility, and your 6-4 goes away. But he did that, and there's no such page, so he can't turn it off. So his only recourse, and he knows what he's doing, is to replace that box.
Okay, the hosts do need to be fixed.
The hosts.
I take it back.
Yeah. So.
Cameron Byrne, T-Mobile. So the problem that we're trying to solve here is that there's not enough internet addresses. 6-4 doesn't solve that problem. It kind of generates IPv6 packets or reachability to some degree. But the growth in IP addresses largely comes from the mobile space, and the mobile space is largely private address space and bogons that don't work with 6-4 anyways. So
did I say that the gateway needs a public address to generate advertisements?
We have seen.
We have implementations that do that. We have implementations
right,
that.
Yeah, absolutely. And that's a substantial source of brokenness in 6-4. But just to say, where's the solutions? What are the fixes and how do they match up? If IP addresses are being consumed in mobile is using predominantly non-routable addresses. Non-routable addresses don't work with 6-4. I block them into my network because they create a lot of invalid half-open sessions in the CGN that's already in place. So it doesn't work.
Yeah. So if you're saying our mobile network's working, then that's good, and our data will show it, which means that we'll be able to turn it on, right?
The only comment that I'll make, and unfortunately, Mark, this is John Brzezowski from Comcast. Mark walked away. I think, unfortunately, what will happen with 6-4, even enabling native IPv6 or some other form of v6 isn't initially going to make the 6-4 traffic drop. As a matter of fact, I think it'll increase before it goes away. Some of the stuff that I had seen a few months ago have given me very good reason to believe that, because there are some things out there that are not. These traffic is not always destined to Google or Facebook or whatever. It's going to someplace else, like some other host on the network, and native IPv6 connectivity will look attractive to some of those applications until you reach a point where there are more native hosts or 6RD hosts on the network. Will that traffic then start to drop?
Oh yeah, I wasn't suggesting that the relays can go away. Yeah, far from it. If the relays go away, it's going to get worse because the packets are going to get dropped.
I'm totally agreeing with you too. That's the bottom line, right?
And yeah, as you said, I think Martin was saying that half the traffic on the relay is 6-4 to Teredo, and it's machines with public addresses talking to machines with private addresses because the app happens to support v6. Now, that's not a good state to be in, but.
Thank you. Sorry, I was just going to say, Haythum is responsible for a huge percentage of our corporate IPv6 deployment, if not nearly 100%. The reason that we have v6 to our desktops and to the wireless. Yes.
Thank you. So I'm part of the corporate network engineering here at Google. Maybe you are aware or not, Google run corporate as similar as an enterprise network and content network as a broad backbone. They run independently, but they are part of the same group eventually. So the deployment for IPv6 motivation, I think, is clear for anyone. The main purpose for it in Google actually is to provide the engineers the ability to connect to v6 backbone and be able to support the application and test and validate the features on the v6 network. Obviously, that's also will come with a benefit added feature. You will be innovation and early adoption of features and support of be able to lead the way and discover the new tool and learn new technology. So what is actually the Google Enterprise Network is a container of distributed offices around the globe. Those numbers may be not accurate, but I think there are more than 19,000 users. Around 70 offices distributed in 33 countries on 5 continents. We use multi-vendors equipment everywhere in the network, and we will talk about the vendor support and the issue we discover during the implementations. Initially, the project started in 2008 by my colleague here in Mountain View, KK, who's not around, I think, today. But in summary, it started as any major Google project, start with 20% deployment, initial small lab deployment where we have a host connect directly with manual DRE tunnel to a single router. Obviously, it's not scalable, very limited support, and that was the earliest stage. And then we moved to dedicated lab, and the lab with a DRE tunnel to a 6-4 routers. 6-4 here mean 6 connected to a 4 backbone. And move away to dual stack the actual network inside the office and run the GRE from the peering edge router. That's the second phase when the one provider was not supporting V6. That's basically was in Ethereum phase, and then till we gone to the phase 3 where we managed to dual stack all the way to the upstream providers. The upstream provider here from our backbone network, beside the MPLS provider recently and several ISPs. So dividing the addressing plan as recommended, /64 for each subnet, even for point-to-point link. That will help the mobile IP. Also, the address allocation is not limited, so why not? We assign /56 per each building. Imagine every building in this campus has /56, and aggregate that /56 to /48 and advertise the /48 on the edge. We have acquired from the registration, the local registration /32 now in ABAC and /40 in Arian. Certain protocol, HSRBv2, work like a charm. So as soon as you enable standby version 2, you'll be able to have host-based redundancy. OSPF version 3 as an IGB and MBBGB. For addressing, we're still using auto configuration stateless because we discover DHCP v6 has very limited support in multiple OS, Windows XP, Mac, and even Linux on the current release on the DHCP. I think you need to upgrade to future version, so it's still not stable. Routing policy is very simple. Accept default from your upstream provider, or ask for default if you don't need the whole routing table, and advertise Office aggregate. So, yeah, what is the main challenge we face so far? I think the hardware vendor platform or hardware support and software support is challenge. In general, certain vendors may support certain features over v4 only, or support IPv6 feature on the software, on the box. So that will have a scalability impact on your support. Service providers. When you talk to any service provider and ask them about IPv6, certain response like v6, we don't have it yet, or we can give you v6, but the SLA will be it doesn't match the v4. So either deployment will take longer, or you will not get the same service level agreement. I feel the ISP are not motivated, okay? Not motivated because of the revenue generated from the v6 might not match what they have when they go to enable a new circuit. Okay, that's any Q&A.
We have a couple of minutes for questions. Yeah.
Do you service internet from each campus, or do you do it from just a few hub campuses? Or
we service the internet from each office individually.
Individually, so
yeah.
You have a separate relationship with different ISPs at each one?
Yes, and MPLS provider and transit ISPs, yeah.
And then between your campuses, you just leasing private lines from carriers, or?
Inside the campus network, we run inside the campus network.
No, between campuses.
Between campuses, we run MPLS and MVBN.
But I mean, what are you purchasing from carriers to interconnect your campuses?
Okay, we have 3 vendors. One of them is MPLS, VBN, and Transit ISP.
So you're using IP from your carriers, or private lines?
We use private lines.
Okay.
Private lines, yeah. Okay.
All right.
Okay, thank you.
Oh, wait, all right, Fumi.
One quick question. How do you manage private extension addresses? Do you allow the use of private privacy extensions?
Yeah, we use privacy extensions, yeah.
So do you have any problems tracing the host that using some certain addresses, IPv6 addresses?
Oh, yes, we had a problem with the private extensions in certain hosts, but we managed to fix it by changing the configuration on the host.
There was another problem as well. We were allowing privacy addresses, and then when we use Kerberos, so trying to authenticate to Kerberos, it would put all of the addresses that it has in its ticket, including everything that's expired or is in deprecated state and only valid for that would never be used for a new connection anyway. So it would send off a UDP packet that was way too big and have 16 privacy addresses in it, none of which were being used.
Also, it caused another problem on the association table on the wireless, where is the privacy extension being counted on the user table and because of don't have service on run of the licenses on the wireless providers. So yeah, that's one. Thank you.
Oh, one last question.
I have one more quick question. Do you have any statistics about traffic volume or percentage of the?
Not with me here, but
okay.
I can share it with you if you want.
Yeah, I'm just curious whether it's a major service or just only a small fraction of people are using it.
It's not as I think it is less than 2% or 3%. We still. I think the internal connectivity is still over V4, but the V6 to the external is quite substantial now.
I see.
You want the last question? Is it quick?
You might have just answered that. I was trying to get an idea of internally, because I assume you have a lot of V6 enabled hosts. So you have the campus that's V6 enabled. Yeah. Your users internally probably use Google services a lot. What percentage, which is V6 enabled, you're probably the ideal case for a campus that's got a lot of V6 running on it.
Yes, but the stat actually don't have it with me here, but we have substantial traffic going on V6, as Lorenzo showed. So we will have enabled the quad A and the A, and you will see a lot of traffic going to the external Google services and the internal, but I don't have the number exactly on my head.
Do you imagine any time in your foreseeable horizon having one of your sites be V6 only?
It's going to be hard for two reasons. You're still going to have someone who's going to run over V4, and you still have to NAT to them or access them certain way.
But you proxy the whole internet, right?
Yes, that's one problem. And the second thing is actually trying to get everything to talk over V6, even inside the corporate network, is challenging. I don't want to mention vendors' name. There are a lot of them a lot of vendors who don't have even a plan to support V6 yet. And
well,
no, sorry. We are not in a business of defamation. We are trying to just address we are trying to address a problem.
Right.
So if I need to support all the applications to my end user, and this is the key aspect of my role, I have to run V4 till all the vendors in the world, or all the vendors I use at least, run V6 natively. Once that's done, I can turn off V4. I will be happy to do that because I think that's the way forward anyway. Does that answer your question?
Almost. I could go a little bit further, but I think we're running out of time.
Oh yeah, we need to get to Ron and get to lunch.
Thank you.
But thank you very much.
Thank you, Haythum. So we were lucky enough last year to have Ron from DREN come give us a talk about the Navy's IPv6 deployment, and he's been great enough to travel at the last possible opportunity to come back and do it again. Let's see here. So, Mr. Broersma.
Okay. So, a little bit of introduction. We've had a project for quite a few years now to aggressively deploy IPv6 in our research engineering networks inside the Department of Defense. And we're doing a case study here of one of the major enterprise customers of that wide area network, SPAWAR, which is a Navy IT organization supporting most of the rest of the Navy. Exists at probably about a dozen locations around the world, dozen large campuses. So that's kind of the context of who we're looking at. And this initiative, what I'm talking about today, is probably a little bit different than some of the other ones or other presentations, because it's real production stuff. It's not just a test bed. It isn't just an ISP view of the world or just a campus view or a system or application view. It's kind of all of the above. It's an end-to-end study. The systems and the users that are the customers in this environment are pretty much all autonomous, a lot of separate projects. It's not like it's one big enterprise environment all controlled by Active Directory. It's a lot of little independent things. It's very heterogeneous. There's about every operating system under the sun that you can imagine in a research environment. And it's not just a few systems, it's everything on the network where we're trying to turn on IPv6. So the goals were push the envelope with IPv6 deployment, see what's possible, see what's missing, see what's broken, and try to get it fixed. Dual stack everywhere is our approach. And where we can, do IPv6 only. So places where we don't have to talk to the internet, we're actually doing IPv6 only or trying to. And we want to share lessons learned, but mostly we want to learn from this experience because we feel we need to figure out all the issues on our research networks before we deploy this on the DoD operational networks, because there, if something's broken, lives are at stake. So that is one of our motivators. So here's some of our progress, and kind of in the order of how we attacked this over the years since about 1999, and then really aggressively starting in about 2003. Wide area network is dual stack everywhere. All of our peering is dual stack wherever we can. We do unicast and multicast. All of our LANs and wireless LANs are all fully v6 enabled. We turn it on every router interface with an address. We ended up renumbering our IPv4 addresses. It took us about 3 years to do it because it gives us some better congruence and makes it some of the operational issues a lot easier, reducing complexity, because you add complexity when you turn on v6. So, we're looking at the O&M tail here. Infrastructure services, all our recursive DNS, NTP, SMTP, all the standard things we enabled soon by dual stacking all of those. Then all support services, the AAA services, authentication, directory services, Kerberos, etc., all dual stack across the infrastructure. Then the public facing services, how we, everything that faces the outside world, the authoritative DNS, mail exchangers, WWW, NTP, etc. Security stack was the really hard one. How do we get this deployed into our secure enclaves? Firewall was a challenge because it took a long time to find a really robust firewall that did dual stack. For a long time, we had duplicate firewalls at a lot of sites. The intrusion detection system was hard. We had an IDS that was written inside DoD, so of course we had to do the upgrade to the code to make it dual stack capable. So we run a lot of snort. So we did all the code upgrades to snort, gave it back to the owner of that code. IPS, the product we were using was Tipping Point. It took us 4 years and about 2 or 3 generations of product hardware to get something that truly did dual stack natively in hardware at line rate. And so we're pretty pleased with how that's coming. So all of those pieces were very hard. It was a lot of work over a lot of years. Then the security services, just a couple examples. We use Windows WSS for updating all our Windows system. We have that all running over v6 now. All of our clients calling in over v6. Also inside DoD, there's a mandated application that every DoD system has to run. It's called the Host-Based Security System, and it's actually McAfee EPO is the product. And we recently got that all working over IPv6, which pretty much amazed the McAfee people because they said nobody else is actually trying this. And we have it working pretty well. And then over the last year, we've had a major push for all the servers, desktop, laptops, basically everything on the network, trying to get it dual stack. Had a large XP environment, and so it takes things like you have to go out manually visiting every machine to try to get it turned on. So that's kind of some of the background. People like utilization slides. Here's one of the sites and compares the v4 traffic to the v6 traffic, and we're at about 10% now. A year ago, I would say we were more like 1%. A year before that, we were at 0.1%. And normally you'd think that, you know, the amount of traffic is sort of, the ratios are going to be equivalent to the product of how much your client base, the percentage of your client base that's up v6 enabled versus how much of the internet is v6 enabled. So when we're close to 100% internally, it's surprising that we would have 10% of our traffic being over v6 to the outside world, because that would sort of imply that 10% of the internet is v6 reachable, which it's not. The reason is YouTube. We were at about 2% until YouTube got turned on, and then we went right up to 10%. So it was kind of interesting. So here's some of our perspective after doing a lot of this. It's really not that hard. A lot of people think you need to make it the organization. From the CIO, the network operators, the network engineering, the people that run the web servers, the IT shop, the security group, everywhere has to permeate the organization. There are too many places, there's a few that get it and others don't, and you can't make progress unless you have it be a corporate culture. You don't want to wait until it's a crisis. You just roll it out gradually as part of normal tech refresh. That was one of our major lessons learned. You don't have to ask for a ton of money to do forklift upgrades. If you haven't started yet, you're already behind. Because if you do it as part of tech refresh, it's like a 5-year cycle. But we're going to be running out of addresses, v4 addresses here in a couple of years. And so it's going to be a crisis for some of you, and you're going to have to do those expensive forklift upgrades if you haven't been working on it. I say don't be afraid to break some glass. Talk about all the worries about SLAs and those few people that can't get to it. Our attitude is, if you're willing to break some glass, things get fixed a lot faster, and that's been our experience. And we don't buy from vendors unless they support v6. And if you do talk to your vendors, beg for feature parity between v4 and v6 features, because it's just really missing out there. And we also, when we talk to vendors, especially when they come and say, hey, we got this great product for you, the first thing we do is say, let's go to your website. Let's see if we can reach you with v6. If we can't, it's call me back when you can. It is a great filter, let me tell you. And it's a good incentive. And, they go off and scramble and eventually get it fixed. So we always like to do these surveys, too, about, how many of the vendors out there really are doing v6, especially the ones that claim they are. So a couple weeks ago was the Rocky Mountain IPv6 Summit. So we did the thing where we looked at all the sponsors. Now, you would think the sponsors of a summit would be the IPv6 evangelists and have v6 enabled all their public content internally, and it's still pretty bad out there. And so we've seen this thing that the vendors aren't eating their own dog food. They just want to check the v6 box and sell you stuff. Here, there are a few notable exceptions. Hurricane Electric, yay, got almost greens across the board. There's a few others. So we like to see that, but it's still too red, and I think that's one thing we need to fix. So at last year's meeting here, talked about a number of things, so I won't repeat that, but you can certainly go back to last year's slides and see what we talked about. One thing we did was trying to get all our DNS zone transfers using IPv6 transport. Also, we moved our entire VTC network to IPv6 only. Our management LAN seemed like a good candidate to make IPv6 only, and we ran into a lot of challenges there and are still working on it. The radius, Kerberos, LDAP, all that stuff, getting it to work over v6, pretty much worked out of the box, except we ran into things like the LDAP client issue, where one of the very important modules is not v6 ready. Challenges with mainstream VPN clients. A big one for us was automating the populating of DNS with v6 resource records. You don't want to do it manually. A lot of the other schemes don't work because DHCP v6 isn't there yet. But we wrote a tool so that if you already have v4 populated in DNS with A and PTR records, there's a way to automatically populate it using dynamic updates to populate with all the v6 records, and so problem goes away. Creating incentives for customers. We have a lot of customers that there's no way to mandate it, and so we have to use incentives to get them to turn on IPv6 in their projects and on their desktops and laptops and so forth. So In the last year, we've had this effort to really try to dual stack all of the systems out there that we don't control. We saw in January of last year about 5% of our systems had V6 enabled, were dual stacked. Before that, I mean, it was only half of that. So we'd made some progress, but still this was way too slow for us. So we had a major internal campaign to try to convince all the system administrators, all the projects, everybody who had a computer, please turn on V6. And it took some education as well, because for all the Windows XP machines, you have to tell them what command to run. You have to have the help desk trained for all the places it doesn't work, because they'll get calls. And so what we had to do was lots of nagging, lots of emails. We set up contests between different groups to see which group is ahead of another group. In some of our servers internally, we removed the A records, and so you could only get to it with IPv6. And then the real good one was when we blocked IPv4 to Google, because I knew this would get a reaction.
So that's the V4 brokenness we see in our measurements, is it? People blocking us?
Yeah. No,
don't do that. Don't do that.
This is a controlled environment. So, but this has the canary in the coal mine effect for us. When there's something broke, you find out instantly. And so that's been very helpful to point those out. And it's a great incentive. So here's one of those pages we put up for all our users, showing by organizational code how you can see how your group is comparing to your neighbor's group. And so this is what we've worked on getting our numbers up over the last year. This is just one of the sites. So why can't we get those last 5%, or why was it challenging for some of those? There were things like all the VMware machines had to be upgraded, all the ESX machines, get them to 4.0 and get it turned on, and trying to convince all the VMware operators to actually do this. It's like, my stuff's going to break. You know, these are the large servers that providing services in our data center, and so they were very nervous about that, and so it took a lot of convincing. All the Windows 2000 users, we got still about 1% of our machines are Windows 2000. Luckily, we can outlaw them next year, because there's a DoD directive that says if it's no longer supported by the vendor, and for us, July 13 is a great date, because Windows 2000 is no longer supported, and so we can actually kick them all off our network and have the policy that allows us to do that. Printers, it's just kind of too hard right now, and so, but what we're doing with all our HP printers are buying all the new Jet Direct cards that support V6 and trying to get as many up on V6 as we can. And then there's just lots of appliances out there, everything under the sun, widgets, devices, and so forth. A lot of little things that just don't support V6 that we're just sort of punting on that for now, and we'll get to them later. A lot of other little challenges we ran into. We were wondering, like, once we dual stacked all the machines, why were the people not doing email over V6? Why was all the Outlook traffic not doing V6? Well, the older versions just don't do it. You have to upgrade to Office 2007 or later. A lot of groups have systems that are under configuration control. It's part of some DoD project and has to look just like the operational networks, and aren't allowed to turn on V6, and so there's just nothing we can do about those. There's a lot of system administrators that just say, I'm too busy, I can't turn it on right now, and we have to convince them, no, you just install IPv6, it's real simple. And they just don't want to mess with it, and so lots of convincing work there. We've had problems like all the rogue 6-to-4 relays, sending RAs. The problem is all the people that have ICS turned on in Windows, because the minute you do that, turns those boxes into a relay, and they start doing RAs, and suddenly they suck all the traffic. The workaround temporarily is just set the router priority on your primary routers, bump it to high, and so hopefully they're our preferred, because the Windows machines will set it to medium. The long-term fix is RA guard. We really need to get that implemented in various products. I see lots of hand waving here. Yeah. Right. Yeah. And yeah. And for us, one of the router vendors we were using actually didn't have a way to set that, and so we had to wait for a feature request to come through and actually implement that. There's various DNS brokenness out there in the world that we have to get around. There's also, we found out that BlackBerry stuff, doesn't work. in a v6 environment, and so that broke some of our users. Oracle lack of v6 support has been a long-term problem, so a lot of our back-end stuff can't be v6 enabled. And then NetApp appliances for doing all our NFS and SMB stuff, CIF stuff, try to make that over v6, but every time we've turned it on, mounts failed. Although I heard last night that they turned it on again and they think they have it working this time. So there's problems like, you'll notice Java never uses v6, and it's because by default they have it, this preference set to false. So you have to go around to all your apps and change this to true, which is not very scalable. There's issues with picking the wrong tunnel metrics. So we see some of our internal machines going through ISOTAP instead of native when they have it, and it has to do with some of the Windows implementations not having the right metrics. Privacy addresses, somebody just asked me about this a minute ago. It's horrible. We hate it. It breaks our environment. There's no central way for us to turn it off. We've been wishing for another bit in the router advertisements that says don't do privacy, or there's got to be some way to centrally turn this off because it's just killing us. We have to visit every Windows machine and manually turn it off, and it's a huge pain. Snow Leopard has been killing us because it doesn't do address selection right in the DNS responses because of how they switched to MDNS responder, and it only listens to the first answer. So I've got some references at the bottom if you want to go read the bug report. This is not fixed yet, and it's a killer for us. And Java on Mac OS, the other fix I pointed out earlier for getting around Java, it doesn't even work on Mac OS X. Printers, you find you can't put an IPv6 address in a Mac saying go to this IPv6 printer, and you put in a bug report and they said that's the way it's supposed to work. You can only put names in there. You have to learn it via Bonjour or DNS, so it's expected behavior, which seems a little bit weird, but that's the answer. We'll go into that one. So we're still working on this network management project, but just basically we're trying to do everything with network management on a separate management LAN, mostly out of band, to all of our infrastructure devices, and we're almost there. Almost everything works. The thing we're still waiting for is we have one application that relies on CDP or FDP to learn topology information, and the tables supported there are only IPv4 addresses, and so we're waiting for LLDP that supports v6, and then we'll be able to actually turn off v4. But you can get an example. Here's one of our tools. We use Inmon for a lot of the S-flow tracking and so forth, and you can see under the IPv address column, most of them are ULA addresses. What's cool about this is the addresses are shorter than v4, and so there's less typing for people who actually have to type the address, so one of the wins of v6. Also, notice there's a few things that still have to use IPv4 addresses, like the Google Search Appliance, which doesn't yet support v6, so a little plug there. Free Radius 2, a lot of people think that you can't make Radius do duals, both v4 and v6 because of things that are in the notes, and if you search the internet, a lot of people say it just doesn't work. You have to run 2 instances. That's actually not true. You can just create 2 listen clauses and it works. And so I point that out because this has tripped up a lot of folks. Part of the management LAN, we have to manage all the UPSs out of the network. This is really one of the appliances we had an issue with, but we found that the new APC network management cards actually support IPv6. So we're replacing all the management cards and getting rid of all non-APC UPSs. And so, we really put our, money where our mouth is and get rid of products that don't support v6 and are investing in things that do. New approach to training. We've learned over many years where we're doing like the, multi-day classes, everything you want to know about IPv6. Didn't help at all. People would go home. By the time they got around to it, they forgot everything, or it seems way too complex. We totally changed it around and said, v6 is easy. Get there in 5 easy steps. And also, we pre-configure all the interfaces on the WAN customer interfaces, and we lay out some best practices because a lot of people were asking about how should I do this? How do I do an address plan? And so we just say, read my lips. Forget about being conservative like IPv4. All subnets are /64. End of discussion. Don't encode v4 subnet values into the bottom 64 bits because we saw a lot of people doing that. We just said don't do it, and don't do NAT, which is another huge argument we have in the DoD because a lot of people think NAT is a security thing. So it's a big argument. So this has really helped because now it looks simple because even in the 5 easy steps, it's here's a copy of the email you need to send to the NOC that says please turn it on and give me my prefix. So a lot of help. So anyway, quick summary. Our biggest issue right now is lack of feature parity. There's just too many places where an important feature is just not, the v6 support is just not there, and it's not. These are the things that aren't covered by RFCs. It's the vendor secret sauce, and that's why we went to that vendor in the first place. And if those features aren't v6 enabled, then it's a problem for us. We think the highest priority for all organizations is to IPv6 enable their public-facing services for a lot of the reasons you've heard here already. And so we're trying to push that in DoD and even make it a national agenda item. Dual stacking networks works well as a transition mechanism, in our opinion. And we're trying to turn off all the other tunneling and 6-to-4 and Teredo and all that stuff. We just absolutely block it in our network. And but there's still work to do before we can turn off v4. We've tried. We're looking for ways to turn off v4 in our environments, but there's still too many pieces that need v4. So that's it.
Wow. Thank you. Amazing. Yeah, we got time for questions. Please.
Ralph Wallace with Command Control. Yeah. Ron, we've been talking for years.
Yeah.
Interesting point, though. With the DREN, as you know, we're currently under contract with SPAWAR to build a Navy command and control system on top of v6 integrated with a SOA framework, and also do all the security engineering involved with that to make sure that we are also in compliance with the certification and accreditation process. You and I know it as DICAP.
Right.
You're running production networks now, and you had to get your authority to operate through that authority at SPAWAR Pacific in order to do that. Going through the workflow, what was your main challenges in order to get that? Because we're doing the same thing in Charleston, okay, for the IPv6 integration lab that we're building for the command and control system we're designing, because we're in charge of the security of it too. So what was your challenges on the
what we
ATO?
Did, in all the doctrine, the policy, and everything about how you do accreditation, secure the networks, and so forth, we just reread all the language in terms of, I know they meant IPv4, but how would you do it with IPv6, and made sure there was an equivalent for every single thing. Demonstrated that to the DAA and got the DAA to sign off on it.
Thank you. It's nice to know that we're doing the same thing.
Okay. Yep.
Dave Hankins, ISC. I want to make a quick note. You mentioned that there's no DHCP6 client for Mac OS X, but actually if you download ISC DHCP4, you can install that on a Mac OS X box and use that as a client. Yeah. Now that's a nice first step. What we'd like to also do is produce a, like in the old days, the first days of the internet, you had an install disk with your ISP that would go and install whatever PPP software they were using and that sort of thing. We want to sort of do the same thing with Mac OS X there, so you can just download that and go and run. So there's progress being made there.
Good. It'd be nice to have it come with a vendor. I mean, we don't want to have to visit the machines. It should just be turn it on and go. So, but I understand.
I don't work for Apple, but I've heard the people that work for Apple speak at microphones saying we will never implement DHCP because of various things. So yeah.
Okay.
Gregory Leibovitz, Juniper Networks. Clearly, you had what we've heard is one of the key things: management support.
Right.
I mean, it's obvious, right? When you look at how much stuff you did and how quickly you did it. So beyond just the governmental mandate, which is, a lot of people could ignore that if they wanted to, especially in the budget times we've had recently in the U.S. What was the trick that you guys used to get this sort of total hierarchical push down about the v6 mandate? And second, how big was the dedicated staff that was working on just v6 projects? So I'm not talking about people who were on a virtual team from the network engineering team who had to help a little bit with the v6 project, but people who were full-time dedicated staff to making all this transition stuff work.
Okay. I think the one real key thing was in 2003 when the DoD CIO put out the directive to try to get there by 2008, DREN was selected as the official DoD pilot. And so that was one of the good incentives. I think for the people working on it, it was just something new and interesting because they were all engineer types and wanted to make it happen. Because we had the DoD selected as the pilot, we had to prove results, and so we had the management buy-in from the highest levels, and that made it easy to get the other buy-in elsewhere in the organization. So top-down is a lot easier than bottom-up. So did it answer all the questions, I think? Oh, staff. No dedicated staff. This was as people had time and interest. There was not a single dedicated person to that. It's a little bit of time over a long period rather than a huge amount of time by just a few people. Okay.
So I have two questions actually. Number one is, what do you do for HTTP proxies? Because the ones we use and the ones everyone uses just don't support v6. So what do you run as an HTTP proxy?
We don't proxy the v6 code. The v6 traffic outbound. We're not a content provider. We have a few websites, but so most of it's our customers going out to the internet. So we do have a proxy, but it's only for v4 traffic, and that's mostly to do local caching and to block access to certain sites. The v6 traffic we just let go through.
Right. So basically, it's the host that makes the decision.
Yes.
Yeah. Okay, that's a problem. The second, your statement to you, when you go to vendors, you say we want feature parity. And,
yes.
That's what I say as well, and it's not working for me.
Right.
So I go to vendors and I say feature parity. What do you want? And I say, well, I want every feature you have for v4, it has to work for v6 in the same way. And they say, no, but we can't do that. That's like boiling the ocean. We need to prioritize. So how do you fix that?
Yeah. Two things. We have the conversation with the vendors, and they say, well, how do we do that? And I say, go have someone go through your entire documentation, and everything in your documentation, make sure it says, here's how you do this in v4, and here's how you do it in v6. And a number of them are going through that exercise and coming up with a spreadsheet and looking for the feature parity. The other thing is we just have entered into a cooperative research and development agreement with one of the defense contractors, where I said, I want to figure out how to solve this problem of feature parity. And so we're going to sort of, turn it into a real research project, talk to vendors, see how we could approach that better, because it is a big problem. Because we've noticed that, we have in DoD, there's a number of efforts to come up with what's the profile of all the RFCs that have to be complied with? What are all the mandates? What's all the testing? There's organizations like JITIC at Fort Huachuca and other, logo programs and other things. Those are necessary, but they're not sufficient. That's what we found. And so how do we get the extra piece? And that's working with vendors. And so we're going to look into how best to do that.
Okay, Fredrik and Ericsson. About feature parity, we get a lot of questions about that. So the answer from our side is which ones do you want first? So
right.
that's the kind of list, because of course feature parity means feature parity. That means every feature there should be parity between all of them. So, but there's an implementation issue here, which is called time and effort. So. Which ones do you want first? That's my statement here. And then about being able to your public services. Ericsson is hosted on Akamai, so maybe we should visit our customer as a customer them and say, hey, when are you going to do v6? And a final question. I realize I'm talking to a defense organization here, but do you have any numbers on OPEX, operation expense, which you are you going to save any money on this, or is it? Are you going to save money when you turn off v4, or are you already saving money on dual stack?
Okay, let me try to answer in order. So in reverse order, OpEx, we don't have hard numbers on that. It is not double the amount of work to support dual stack, but it is between 1 and 2x, certainly because of the additional complexity. But I don't have hard numbers on that yet. The other question was the feature parity thing. Absolutely, prioritization is a key, and usually when the vendors come up with that matrix and they say, here's all the things that don't do v6 yet, that's the first thing they ask us, what's the priority? And we'll prioritize because it's based on operational need. And then what was your second question?
No, that was I was mainly what you could refer to. Do you think you will spend some OPEX when you turn off IPv4? Because you said, you kind of hinted that it was like 1 times something more expensive to do dual stack, not two times.
Right.
So it's like, is the v4 part the fraction there, or is it the one? So do you kind of expect to get lower
It's why we went through all the effort to do things like congruency in the network and changing our v4 addresses so that the OpEx would be lower.
So it's not to get to sleep through the weekends, or
not to get what?
To sleep through the weekends, not being able to support your customers there. So
yeah,
no, it's okay. Understand.
Yeah. Mm-hmm.
Okay, thanks.
Okay, good.
Thank you very much, Ron.
Okay.
Fantastic.